Hello, hello. If I could get everyone's attention real quick, we're about to get started. I want to thank everyone for coming out to week one of RIT Sec. Everyone, give a round of applause. You made it. You made it through the first week. All right. I appreciate the turnout. It's amazing to see so many people here and so excited about RIT Sec. I'm going to hand it off to Mr. Kenny Anderson, and he's going to run you through some announcements.
What's up, guys? Welcome back. It's week one, or week two, I guess. What? Then they can't hear me. Can you guys hear me still? Okay. Give me a second, I'm sorry. Okay, welcome back. Announcements. Wait. Please sign in. I was informed how the bot works. So head to the sign-in category in Discord, click the general meeting channel, and react to the message. I'll give people a few seconds to do that. Join the club Discord. I hope everyone's in it, but if you're not, the QR code is on the screen now.
You need to be in there to sign it.
This is also very true, yeah. We good?
You need to reorder those slides.
We do. I'll do it. Okay. Check the calendar. All our events are updated on the calendar. I would assume you guys are on the calendar, but if you're not, head to calendar.ritsec.club and add that. Also, the mailing list. We send out weekly emails. Let's go. Mentorship groups. Do you want to come up, Anthony? You can scream if you want, but they can't hear you on stream. No, here. Use the mic.
This is the mentorship sign-up QR code. So the mentorship program, we're going to pair with like older students with anyone who wants to sign up. You're going to do a cool project over the course of the semester/semesters. And we have a lot ranging from like everything in cybersecurity. We have like rubber duckies, kind of just everything. And it'll be really fun. So here's the sign up to be a mentee, and this will probably close on Sunday-ish. We ball.
Please sign up. It's oh so fun. I'm not clipping it. Okay. Continue with our announcements. We are going to Letchworth State Park tomorrow. If you didn't already sign up, please find a ride and come. It's going to be a great time. Meet the sponsors. Clap it up for the sponsors. Keep going. Oh, yeah. Oh, yeah. Keep going. Oh, yeah. Uh-huh. Follow our social media. We're going to be more active this year. It's going to be a great time. Ooh. Okay, now we're going to have Introduction to Linux with Mr. Daniel.
Forgot to put a slide in about this, but following our social media, if you happen to want to run our social media, we have a sign up to be the social media head of RIT Sec. You can manage our LinkedIn, our Instagram, our Twitter, etc. There's more announcements in Discord. We also have a web admin who manages our website. Those signups are in announcements. There's more details there. Thank you.
Okay, as I was saying before, week one, Intro to Linux with Mr. Daniel. Please clap for him. You know how to work the slides, man? You know how to work the slides? You know how to work the slides?
I do not.
Just click the arrow.
Okay.
That'd be good.
Cool. Hello, everyone. Does everyone hear me okay? This is good? Okay, awesome. I'm Daniel. It's nice to see a room full of people. This is very exciting. All right. Yeah, I'll be talking about Linux. We're going to have a good time. So first, what is Linux? It's an operating system, kind of, not really. I say that because like there's a whole rabbit hole that you can go down of like Linux, GNU type thing, but for all intents and purposes of this presentation, you can think of it just as an operating system. But more than that, it's like a bunch of operating systems because Linux is just the kernel, right? And what people do is that there are multiple different, we call them distributions of Linux. You can think of them as like ice cream flavors, right? It's Linux, but it comes in a lot of different flavors, and they're all a little different, but it's all Linux, right? Yeah, so Linux is, people say it's very customizable because it's open source, right? So What I mean by that is that you can like go on GitHub and find the entire source code of Linux, clone the repository, compile it from source if you wanted. It's all there. It's all open source, which leads to it being very customizable, which leads to there being a lot of different distributions because anybody can go and create their own Linux distribution, right? Makes sense. And yeah, people that use Linux, it's a very kind and welcoming community. There is absolutely like no gatekeeping. Nobody is judgmental. We treat every single distribution equally. Yeah, by the way, I use Arch. I made a tier list for you to show you all the different Linux distributions, and I can't name half of those logos. But anyway, Arch is the best. That's my opinion. And man, those slides kind of got cut off there. Okay, that's fine. So I'll just kind of walk through some of the more common ones that you'll be hearing of. Yeah, Arch Linux. That one is for gods. I say that because Arch is like a very minimal install of Linux. So you'll hear people saying I run Arch, whatever. It's supposed to be a bit more difficult to install and get set up and running because it doesn't really come with anything except like just a shell, and that's pretty much all you have. Some people will say Arch is also for masochists. I like to think, well, maybe gods are masochists, So yeah, Arch, good time. Then there's Manjaro, which is for wannabe gods. I say that because I actually never used Manjaro, but what I've heard is that it's Arch Linux, but it kind of like holds your hand through the installation process. So I mean, it's Arch for people who don't have self-confidence, really. And then there's Kali. You've probably heard of Kali if you're in here. Kali Linux. It's for hackers, or it's basically just Debian, which is another distribution, but it comes preloaded with a bunch of different tools that people use for all sorts of hacking things, CTFs, whatever, like Metasploit, all those tools that you'll need. You're going to use it in your classes. You're definitely going to get familiar with it. Some people will tell you about Parrot. If somebody runs Parrot, you'll know because they'll tell you they run Parrot. And Parrot's basically Kali, but kind of more like more user-friendly, I suppose. It's like something that you can get away with daily driving. Kali is just like a toolbox. Parrot's more like something that you can actually use. There's Ubuntu, which kind of got cut off there. But yeah, Ubuntu is like very easy. It's for everyone. People, I mean, if it's your first time like installing Linux on something, people will usually recommend that you do it with Ubuntu because it's easy to get started with. There's good documentation for assisting and all that. It's good. And also, you completely cut off is like CentOS, I think I put on there. CentOS, you're going to use it for when it's already there. It's pretty much like CentOS is kind of marketed towards more of an enterprise Linux software, sort of. So companies, corporations, they kind of use CentOS because it's stable and managed and safe, so it works. And then also cutoff is, I think, Fedora I put on there, which is also by the same people who do CentOS, I believe. Red Hat Linux is the name of that organization. And yeah, Fedora is like CentOS, but for people to use, not companies. Yeah. All right, so we talked about distributions, but I think it's helpful to actually see these things and not just, talk about them, because the way the human mind works is that when you look at something, it's a lot less scary. So that's what Ubuntu looks like, right? Just like a normal computer. It's pretty boring, honestly, Just, yeah, Ubuntu, wow. And then you have CentOS. It's a lot more boring. It's very lame colors. There's like 3 things on that desktop. But yeah, it's gross. It's very, very simple, okay? Then there's Kali. This is a bit nicer. You're going to get familiar with that logo a lot. You're going to get familiar with Kali a lot. It's very good to have, like, if you're in this room and you're doing cybersecurity type stuff, I definitely recommend having a Kali VM somewhere, or a Parrot VM if you're like quirky and cool. Then there are also meme operating systems like Among Us, which, yeah, that exists. It gets better. We have Hannah Montana Linux. If you run this, I have major respect for you. They have to see the truth. Yeah, we also have Ubuntu. This is another good one. I'm pretty sure just Ubuntu, but Ubuntu. That's probably a lie, though. You should look into it if you're curious. Yeah, so Linux can be silly, and like I said, big part of that is because it's open source, so anybody can go in and get the Linux repository, add to it, take away from it, customize it to release whatever Linux distribution they want to release, right? It's very easy to do. It's all free, very cool. So let's talk about the shell. The shell, right? Your new best friend. I say that because everything that you're going to be doing on a Linux box, you're probably going to be doing it from the shell just because it gives you so much access to everything. It's like, it might seem scary at first, but once you get comfortable with it, you're going to love it. I certainly do. It makes you look really cool when you pull up a shell and you start typing stuff into it. So like, the person sitting next to you is like, whoa, you're hacking. Yeah. It's got many names, I call it the shell. People will call it a terminal or a command line interface. Sometimes people will just refer to it as bash, right? That kind of a thing. Hacker window, whatever. Yeah, it's very strong. Like you can do pretty much anything that you can do on the box, you can do it from the shell, right? It's your go-to way to do things. It's very efficient if you know what you're doing. Like it's a lot faster to do things from the shell than by clicking on buttons and windows and things, which is why we love Linux. And yeah, if you're doing this kind of stuff, it's essential to know. You can't just not learn how to use this thing. It's everywhere. It's necessary because there are tons of things that you can only do from the shell. So you kind of have to do them from the shell. And yeah, it's lightweight. You can it doesn't take up much space on your computer or whatever. And they come in different varieties. There's SH, Bash, and ZSH is like the cool modern Bash. So yeah, but they're all pretty much the same. Like if you learn one of them, you learned all of them. So cool, nice. So about the shell, right? RTFM stands for what you guess what the F stands for? Manual. So yeah, the man pages. The manual pages, right? So this is if you don't know what a command does, you're going to refer to the manual. And the manual is accessed by just typing the man command and then whatever it is that you're trying to figure out, right? So in that picture up there, you see man ls, because I want to know what ls does. And then it prints out nicely into the terminal and it shows me what ls does. Very nice. It also works for configurations, by the way. Man will also show you different configuration files and stuff like that, which would be very useful. Definitely make it a habit to use. And another way to do this is you can Google what does ls do, and you will just be brought to the man pages on Google. So you can save yourself some time by just using the man page, or if you really just don't want to look at it in the terminal, you can pull it up on Google, I suppose. But sometimes you won't always have internet, so it's definitely good to know and to get used to just doing it from the terminal. And before you do anything, just refer to the man pages. It's very important because you'll find a lot of cool stuff in there, sometimes things that you might not have otherwise found. And sometimes you can use those things to get creative and maybe do some, find a way to, it's definitely possible to just go through different commands, man pages for them, and then just make red team tools based off that kind of stuff, right? There's some really weird stuff in the man pages sometimes. Moving on, right? So let's talk about the Linux file system. This is another really cool reason why I like Linux, because to me, it's very simple and straightforward. You have a root directory, and everything is just kind of under there. It's all organized in a way that makes sense. And everything in Linux, asterisk, maybe not really everything, but everything in Linux is a file. You'll hear that a lot, everything is a file. That's it's kind of true, right? Files are files, directories, files, executables are files, sockets are pretty much files, configuration files are files, and mounted devices are sort of files, and processes are also sort of files. But they're represented as files, so you pretty much treat them as files. There's just one root directory, everything is kind of under there, then you have your common directories and stuff like that. And also pictured, you see the file command. You can use that to see what kind of file something is, right? That first picture tells you that, hey, that directory is a directory. This is a 64-bit executable. That's a symbolic link, and so on, right? Makes sense. Yeah. So we'll talk about some of the popular destinations. Static, because these don't change, right? So /, yeah, that's your root directory. Everything is under there. That's, home base, kind of. I want to call it home base, but that's where everything is, right? The root directory, it's a root. /etc, so this is where all the configuration files are going to be. Well, most of the configuration files. You'll have some in your home directory, but for like system-wide applications, it's probably going to be in Etsy. There's /home. This is like whenever you create a user, they'll get their own directory in the home directory. /mount devices. Proc is where we'll find different stuff on processes. Bin and user bin is where all of those Linux binaries are going to be, and whatever else binary you decide to install. If you want to put it in there, you can do that. And then also sbin and, I should say user sbin, but that's where binaries accessible to the admins are. So then relative paths, right? So dot, I don't know how well it shows up, but if you just type in dot, that's your current directory. 2 dots will take you to like the parent directory of the directory you're in. So if you're in like /home/ your name /documents, and then you type in, change directory to ... you'll go up one directory, basically. And minus is the previous directory you were in. So it's not like the one above you, but just whatever directory you were in previously, which oftentimes is the one above you. All right, moving on. So let's talk about users and groups. All the users can be found in Etsy password, which is a file. And we'll take a closer look at that later. But yeah, pretty much every single user has a user ID. The root user has a UID of 0. Regular users have UID starting at 1000. And then, different softwares sometimes have different users in the Etsy password file. So when you look at that, you're going to see like a bunch of stuff, and you're like, whoa, I didn't create those users. And that's because the software that you're using did, and it uses those to execute different processes and stuff like that. So yeah, and there's also groups. They can be found in Etsy group. And users can be in multiple groups, and they're kind of used just for controlling different permissions to things. Organizing your users and granting access to certain groups, denying it to certain groups, that sort of thing. A useful command for figuring this kind of stuff out is who am I? That'll tell you what user you are, but we'll look more into how to find out who exactly you are. All right. So file permissions, the basics, right? Everything is owned by a user and a group, and also an owner. The modes are read, write, and execute, which are represented by RWX. So kind of like in that photo, you see that, right? I mean, it's kind of, just look at the photo. It tells you, okay, so the first group from the left, all that dash, that tells you whether or not it's like a directory, or sometimes they'll say something if it's a symbolic link. If it's a D directory, if it's not there, it's a file. The first 3 letters to the right of that are the permissions for the owner, right? So RWX, that means that the owner has read, write, and execute permissions for whatever that thing is. Then the second group is for the groups, and the second 3 are for the for others, right? If you're not the owner or the group. So that's kind of how permissioning works. It's not too complicated. There's also a numeric way of looking at this, but since this is intro to Linux, I won't really be talking about that. Just know that it exists, and you should definitely learn it because it'll make your life a lot easier. So when you see the file permission is 777, that means that has permissions to everything. Sometimes we'll see 755. So it's just good to know what those are, and you should definitely learn them. And there are also special permissions, right? So SUID, that means that it can be executed with the owner user permissions. SGID with the owner group permissions. And then, there's a sticky permission, which you'll see sometimes, which says only owners of files can delete files in sticky directories, so nobody else could, only the owner. And to mess with permissions, you can view the permissions of things with ls-l. You can set the different permissions with chmod. You can set owner with chown, and you can set group with change group, right? Maybe you'll memorize those, maybe you won't, but this is intro, so just know those things, maybe take notes. But the best way to learn how to do this stuff is really to just get on a Linux VM and start actually doing these things. So, have fun with it. I already talked about numeric representation, and also sudo. So if you run something with sudo, you're running it as root. So that's good to know. If you don't want to run it with those permissions, you want to run it with root permissions, you do that using the sudo command. It'll ask you to enter in a password, and you'll enter in your password. And if you're part of the sudo group, then you'll be able to run it with sudo privileges. Okay, that's true, but sudo for most intents and purposes. Okay, so let's talk about actually moving around and going around, going places, right? Actually navigating your way through the file system. So first, before you can start going places, you got to figure out where you are. So just who am I anyway, right? You have the who am I command, that'll tell you what user you are. You have groups, that tells you what groups you're in. And ID will tell you all your different, it'll tell you everything, right? So what user you are, what groups you are, all the different IDs associated with those things. And yeah, so that'll tell you that stuff. Where am I? Type in pwd, it's print working directory, and that'll tell you where you currently are, as you can see in that bottom photo. And why am I? Linux will not answer that question. Yeah, okay. So actually moving around. So to go from point A to point B, it's very simple. You type in cd, which stands for change directory, and then wherever you want to go. Makes sense. Syntax is pretty simple. A lot of commands are just going to be like command space, the thing that you're going to, or the thing that you're changing, right? Just as like a general rule of thumb. There are some shortcuts that, like if you remember when I talked about those relative file paths, right? So cd tilde will take you to your home directory, which is like your /home/ whatever your username is, right? Your home directory. Cd ... will take you up one directory, which can be very useful. So yeah, you can see in that photo on the right, just kind of all those things as they're working, right? We start in the home directory, we go to documents. Wow, now we're in documents. We go back, and now we're back in the home directory. cd root, you're in root. If you do cd minus, we go back, it shows us tilde because we're back in the home directory. Because if you remember, minus is the go to the previous directory you were in, not up one directory, but the previous directory you were in, right? So, yeah. Okay, so finding where to go, okay? So you know you want to go somewhere, but how exactly do you get there, right? Or like if you want to look for something and you want to get there, how do you do that? If you type in ls, it'll kind of print out all of the files and directories in your current directory. There are different options you can do with that. ls-l will show you more details like the permissions, that type of thing. -a will include hidden files, so that's any file that starts with a dot. Like if you used GitHub before, there's like .github, that would be shown if you use ls-la, right, as an example. And then you can also combine them like ls-la. You can do that pretty much with all of the commands. You can combine the different options just by putting them together under one tag or dash or however you want to call it. There's also the find command, which is very useful. It's definitely a good idea to know how to use this because you're definitely going to find, there's going to be things and times where you know what the file is, but you don't know where it is, so you don't know how to get there. And the find command is the solution to that, right? So it's got a kind of a weird syntax, but basically it's find, then the directory to search under, like where your starting point is, then your options. Your options can be the name, which is the name of the file that you want to look for. The type, so like if it's a file, a link, directory, whatever it may be, if you know that. The user of who it's owned by, permissions, and that uses the numbering scheme that I alluded to earlier. So another good reason to know how to do that is because you can use it in the find command to make your life easier. And also for files edited within the last n minutes, you can do mmin. So yeah, definitely learn the find command. Okay, so let's actually interact with files and start touching things. Creating and editing files, right? So there are many ways to do this. The general syntax is going to be like, okay, your text editor space, the file that you want to create and or edit. So touch is the basic way of just creating a file. It's going to make one and not edit them. You're just going to like put the file there. Make dir is going to make a directory, like a folder. Vim is the text editor for gods. So Vim is like, it's a text editor. It's a bit tricky to use at first, but if you learn all the different shortcuts and how to use it, it can really speed up your workflow. It's very good to know. If you want to know more about it, there was a presentation last semester on the Railic YouTube, so definitely check that out. Then there's Nano, which is a text editor for people who don't want to learn Vim. There's gedit and Emacs, which is a text editor for people who are scared to use a terminal because those are like a graphical user interface. You can use them. I use them sometimes just to make my life easier, but definitely just get used to using Vim or Nano. There's VI. I don't know why you would ever use VI. It's just Vim, but worse. It's installed by default, though, so like before you install Vim, you have to deal with VI for a bit. There's also the echo command, which you can use to just kind of quickly append or write to a file. It's not necessarily like a text editor, but you can use it to like print something into a file, which can be useful sometimes when you don't want to like pull up a whole editor. Okay, so reading files. There are also multiple ways to do this. So there's cat, and there's a beautiful picture of a cat to remind you of that. That just prints everything in a file to your terminal, right? You type in cat and then the file name, and it'll tell you everything that's in there. Awesome. There's less, which kind of gives you more control over the output. You can like scroll through it and organize it in ways to make it more pretty. There's more, which is less but worse. I think, yeah, I mean, I don't actually remember what the difference between the two are. Just always use less. More does not add anything, really. And then there's file, the file command again, which tells you what kind of file it is. So like, if you try to cat out a binary, you're probably not going to get anything useful, right? So you can use the file command to say, okay, is this a binary or like a text file? And that can be useful in multiple situations. Okay. So let's talk about grep, because grep is really important. You're going to be using grep a lot. What it does is that like, if you're looking for a specific string of letters or numbers in a document, you can use grep to kind of find those and where they are. And so like if you have like a huge document and you only want to find, okay, where does it say this thing? Then you say grep this thing, and it'll tell you where that is, right? So the basic syntax is grep, and then the pattern, and then the file. Although most of the time, and oftentimes, you're going to be like piping into grep, and we'll talk about redirecting stuff and piping stuff later. But yeah, usually it's useful for finding text in big files. It uses regex for the patterns, so yeah, learn regex. You won't regret it. It's got a lot of like, there's a lot of times where regex will pop up, and you're going to have to know it, and it's going to be a pain in the butt, but it's good to know because you're going to need it. And yeah, it can take redirected output, which is how you're going to be using it most of the time, right? Oh yeah, and that, like that meme says, you're going to use it a lot if you're looking through logs and stuff. So if you're blue teaming and trying to find when like some service went down, you can go through the logs, grep for that service, and kind of get more information, right? Or if you're looking for something specific in mind, you can find that too. Yeah, so let's talk about moving and removing files. So there's the mv command, move, just move a file from place A to B. So the syntax is going to be move the file that you want to move and then where you want to move it to, right? You can also use this to rename files. This is actually the way to rename files. You would just move it in place and then give it a different name, pretty much. There's rm for removing files, like getting rid of them. Syntax, again, very simple, just rm and whatever you want to remove. If you're trying to remove a directory, you have to do that with a recursive option, which is -r, so like rm-r and then the directory. There's also rmdir, which you can use on a directory if it's empty, but usually you're just going to use rm-r because most of the times when you're deleting a directory, it isn't empty. If the directory is being stubborn, like if it's giving you a bunch of stuff, like, oh, you can't do that, you just do rm-rf, and it'll do it for you. Just be careful with this because like it will delete stuff. Kind of cut out there is the cp command, which is copy. Very simple to the move command, pretty much the same syntax, right? You're going to copy the thing that you want to copy and then the place you want to copy it to. Cool. So we'll talk about curl and wget. These are going to be how you get files that are in the internet, right, that aren't on your machine. So curl, it's like C URL because I'm pretty sure it came from like some C library for interacting with URLs. Yeah. So syntax, I mean, there's a lot that you can do with curl. You can like forge different get requests, different post requests even, stuff like that. But if you're just using it to get a file from somewhere on the internet, you're just going to do curl and then the URL. And then it's just going to, I'm pretty sure it's just going to print it to your terminal. If you actually wanted to redirect that into something that you can save, you do like the little greater than sign, and we'll get into that. But yeah, some common options are like -x. That's going to be how you define your request method. So if you want to do like a get request or a post request, that's how you would do that if you want to like manually forge it. And then like -d, which is going to be the data to send if you're doing like a post request type thing. So you might see that sometimes. There's wget, which I think is actually like on default for most Linux systems is wget, not curl, which I always thought was weird. But yeah, most things come with wget. And it's pretty much only used to just download stuff from the internet. So basic syntax, wget, and then the URL. Yep. Okay, so let's talk about some other things, right? And stuff. So environment variables. Environment variables are ways to store information in a shell session. So they're active for the duration of that shell that you have open. And they are set with the export command, right? So if you want to export a environment variable called new env equals something, that's how you would do it. You just export the name of the variable you want, and then you set it to the thing that you want to set it to. Crazy. It's useful for keeping track of short-term values. So like if you're doing stuff like hack the box, it can be pretty useful to just set the IP of the box you're trying to hack the box into. You can just use the export command so you don't have to memorize that IP address and enter it in every single time you want to do that. That kind of stuff, environment variables can be very useful. And then if you ever want to display your environment variables, you do that with the print env command, which will print out all of the environment variables you currently have set. Also, like, there are a ton of environment variables that are set up anyway that you didn't necessarily set up. They're pretty much just other ways to configure things, really. Just different options for doing that. So let's talk about bash rc and zhrc. So these are like the configuration files for your shell. If you're using bash, it's bash rc. If you're using zsh, zshrc, right? And the file name is actually going to be .bashrc or .zshrc. So they are hidden files, but they will be in your home directory. You can do a bunch of really cool stuff in here. You can create aliases, which is just like creating an alias for a command, right? So one that I like to do is that first picture, Pi server. So whenever I want to put up a Python server, I just type in Pi server instead of that whole command that you see to the right of it. And it just does that for me. Very useful. You can also create functions, which can be pretty cool. Like the best use that I found for that so far is that make cd thing that you see there. It's pretty much just saying like, okay, type in make cd, and when that happens, we're going to make a directory and automatically change our directory into it, so we don't have to like make dir directory name and then cd directory name, right? Just save you some time. But besides that kind of stuff, right? Like the bash rc files, that has a ton of other configuration options. So key mapping, that type of thing. You can customize your prompt. You can edit your path variable, and your path variable is pretty much where your shell is going to point to for when it wants to look for certain binaries. So like if you don't want to type in the full path to the binary you want to run, you can put it in certain locations like /user/bin, which is pointed to inside of your path variable, which is defined in your configuration file, so that you don't have to type in that whole directory name, right? You just put it in somewhere that's defined in your path, and then you can just type in the command that you want to run. Pretty useful, and you can edit that path variable in these configuration files. You can also set all your environment variables so that like when you start a session, it's there by default. It's important to mention, right? So whenever you start like a new shell, it runs through the bash rc pretty much. So if you wanted to do something on startup, whenever you open a new terminal, bash rc is a good place to put it. And for red teaming and blue team competitions, sometimes you'll see some funny stuff in there. So another thing to keep in mind. Package managers. So this is another really cool thing about Linux, right? Because like if there's something that you want on a Linux machine, like some tool or some software, you can pretty much just do like, okay, package manager and get the thing, right? It's very simple. You don't have to go through a bunch of weird executables on the internet to get it. But yeah, different distributions, right? They'll have different package managers. Ubuntu, Linux Mint, and most Debian-based distros are going to use apt. You're going to get familiar with this when you get familiar with Kali, right? Arch uses Pacman and Yay. Yay is like the, it gives you access to like a community-created database of software. So you're going to be using Yay a bunch if you use Arch. It's pretty cool. And like the Red Hat Linux distros, they use Yum and DNF for the most part. All right. Logs and system information things. Yeah. So if you want to look at like history of when stuff happened, and you want to make sure that you can go back and see what commands you typed in, or when things are broken, and you want to know, well, how did they break? You have to look at logs. So most of those are going to be in /var/log. Your history stuff is going to be in either of those two directories, depending on if you're using bash or zsh. Dmessage is where you're going to get a bunch of the kernel stuff. So if you're like working with kernel things and you're going into kernel panic, and you're like, man, why is that happening? Dmessage will tell you most of the time. Or if you're like, working on some kernel module and it's not working well, dmessage will tell you. But you're probably not going to be doing that if you're just doing intro to Linux stuff, so don't worry about it too much. Journal.ctl is it's like the systemd logs. So systemd, it's like a service on Linux that manages all of your other services. You can use it to like enable or disable things. So whenever one of those services breaks, those logs are going to be in the systemd logs, which you can find with the journal.ctl command or other various systemctl commands. But journal.ctl is a good place to start. Okay, so let's talk about SSH. You're going to be using this quite frequently as well. It stands for Secure Shell. Even though there are two S's in SSH, just don't worry about it. So remote access, right? This is if you want to like go from one machine and you want to log into another machine remotely. You use SSH. It uses asymmetric key pairs for authentication, a public key and a private key. So you can there are multiple ways to authenticate using SSH, but pretty much you're going to take someone's private key, put it in a certain directory, and then you can SSH to them, right? Or you can type in the password of the user you're trying to SSH onto on the remote machine when it prompts you. The usage is pretty simple. It's SSH, the username, at the IP that you're trying to go to, right? So there's an example, right? If I wanted to SSH as the Daniel user at that IP address, then I would type that in. It would prompt me for a password, probably, and then I would type in that password, and I would be logged in as that user on that machine from my machine. So then I can, interact with it from my machine. So it's very useful for when we want to do those things, right? Which you will be doing pretty frequently. All right, so like I said earlier, we're going to take a closer look at etc password. This is a pretty important file because it's where all of your users are. It's not what your passwords are. You would think so, but no, that's somewhere else. That's etc shadow. So etc password is, like I said, where all the users are going to be. And as I mentioned kind of earlier, there are like a lot of those users, right? So I don't know, the FTP user, the DHCP user, right? Those aren't users that you might have necessarily created, but they are used by different applications and services in order to run different applications and services. So that's why those are there. If you look at towards the bottom, right, this is some screenshot that I took from the internet. So this guy's user is named Nishant, and his UID is 1000 because that's a user that he created. And when you create users, their user IDs are going to start with, they're going to be starting at 1000, right? So if I were to create another user on this box named Daniel, it's going to be 1001, right? And the basic format of what all that stuff is, right? It's going to be the user and the password, which, as you can see, is all X's because nobody puts their passwords in etc password. So it's actually not going to be there, but that's what that X is supposed to be there for, even though it doesn't really do anything. The UID, the user ID, the group ID, yep, and then any comments, right? Like that dbus one has the comment system message bus. Then the home directory of that user. So if we see, if we look at Nishant again, his home directory is /home/Nishant. And then also their default shell. So whenever they launch a terminal window, that's the default shell that it's going to use. Cool. So let's talk about pipes and redirection. So whenever I was saying earlier, you can redirect this output into something so you can actually save it. Or if you want to string together multiple commands, this is how you do that. So if you want to redirect output, let's say I want to, let's see, I'm curling something, right? From the internet, we're using the curl command. If I want to curl this URL and output it as something, I would say curl the URL, and then I would type the greater than sign, and then the file name that I want to save it to, right? So that's how you would do that. So the one greater than sign means write to it, right? So if there was already something in that file, it would erase everything in there and just replace it with whatever you're then putting in. If you want to append, then you would use two of them. Make sure not to mix that up because you can definitely run into some accidents with that. If you want to input to a command, right, you don't see this too often, but it does pop up. you would use the less than symbol. It's kind of the same idea, just less than symbol for inputting into a command. But you really won't be using that much because you're going to be using pipes for most of that kind of stuff. And the syntax for that is just command and the pipe, and then the next command that you want to run. But this is different than like run this command and this command. This is like run this command and then pipe the output from that command into this one, right? There's a bit of a difference there. Yeah, so an example that you're going to use pretty often is like ls-a, and then you're going to grep for a certain file if you want to see it, if it's in that directory, right? Like in that example, we can see that we use the -a option to show hidden directories, and we're grepping for the dot to find all the hidden directories inside of a directory. So like, yeah, that's an example. Cool. So I want to talk about Rice for a second because this is like one of the more fun things about Linux. If you remember back to when I showed you all of those weird photos, most of them were kind of boring of different Linux distributions, right? Like when we looked at Ubuntu and CentOS, it was pretty lame. But it doesn't have to be like that. You can get pretty creative and have a lot of fun with how you want your Linux thing to look like. The reason why it's called Rice is that it comes from the car modding community. I believe the story goes that they would like import cheap Asian cars and then modify them, and they would call that modding process ricing. So that's where the word comes from. Yeah, just make Linux look pretty, more aesthetic, more functional. You can do, customize your window manager, your desktop environment, make your applications look better, that kind of stuff. And it's a real reason to use Linux because, I mean, if you want to sink hours into making your environment the way you like it to be, then you can do that in Linux, and it's really cool. Yep. Okay, so let's take a look at some of this stuff just to show you how cool Linux can look, right? So, I mean, like, that's pretty nice. Yeah? Well, I mean, that's a nice desktop wallpaper. They matched it all. Very pretty. Personally, not my taste, but it's pretty good. Let's look at the next one. Pretty similar. Same idea, right? We're just making things look prettier, If you're more into green and brown colors, maybe this is the one for you, And a lot of the times you can find, like, people will post their dot files, they call them, all their configuration files. So you can pretty quickly set up your Linux environment to look however you want it to look like. It's actually not a bad idea for, like, a first project. If you want to learn Linux, it could be pretty fun to just start with a very simple install and just start modifying things to make it look the way you want it to look. You'll learn a lot about different configuration files, editing files, where all that stuff is stored, how to run all those different commands. It could be a pretty good way to just learn Linux. Plus, then you get something pretty at the end of it too, right? Yeah, moving on. This is actually mine. I know, I'm so cool. I don't Arch, by the way. Yeah, so whenever I turn on my computer, that's what I'm greeted with. And yeah, I figured that would be a fun way to end this presentation. So, are there any questions? Preferably ones I can answer. Awesome. We love to see it. Thank you.